Today we're going to talk about two important ideas in statistics and scientific research, the null hypothesis and the alternative hypothesis. Don't worry if these sound tricky. By the end of this video, you will know what they are, how to set them up, and why they matter. What are null and alternative hypotheses? When researchers test a hypothesis, they usually start with two statements. The null hypothesis states that there is no significant effect or no real difference between the groups or conditions you are studying. Think of it as the no change or no difference claim. The alternative hypothesis is the statement that there is a difference, an effect, or a change. It's what the researcher believes might actually be happening. So, how do you set these up? Let's look at a simple example. Suppose you want to test if a new type of fertilizer makes plants grow taller than when they were grown with no fertilizer. The null hypothesis states that there is no difference in the average height of plants grown with the new fertilizer and those grown without it. In other words, the fertilizer doesn't do anything special. The alternative hypothesis states that plants grown with the new fertilizer will have a different, in this case, higher average height than those grown without it. In a real experiment, you would grow one group of plants with the new fertilizer and one group without. After some time, you measure their heights. Then, you use statistical tests to decide which hypothesis seems more likely. If the numbers show a big difference that's unlikely to be due to random chance, you reject the null hypothesis and accept the alternative hypothesis. But if the numbers show only a tiny difference or no difference at all, you do not reject the null hypothesis. It doesn't mean the null is proven right forever. It just means that, with the data you have, you don't have strong evidence that the alternative is true. Imagine you are testing a new teaching method to see if it improves math test scores. The null hypothesis states that the new teaching method does not change the average math scores compared to the old method. The alternative hypothesis states that the new teaching method leads to higher average math scores than the old method. If your test results show students using the new method score much higher, and this difference is probably not just luck, you would reject the null hypothesis and say the new method works better. In summary, the null hypothesis is like the default position. No effect, no difference. The alternative hypothesis suggests there is a meaningful effect or difference. You collect data and use statistical tests to decide if the results are strong enough to reject the null hypothesis in favor of the alternative. Understanding this is a big step in thinking scientifically. It helps ensure that we have good evidence before we make conclusions. That's it for now. Thanks for watching and see you next time.